In this video, we'll discuss problems and conceptual exercises of chapter 3 from the book James Walker. Now in this question we are given that a football is thrown with an initial velocity of 16.6 meter per second x cap. So this direction will be taking x and this is y, right? So this ball is thrown with an initial velocity of 16.6 meter per second x cap. Now after the ball is thrown horizontally, the ball will follow the path something like that. Right now, the average acceleration of the football over any period of time is given by this value. So acceleration we have minus 9.81 meter per second squared y cap. Now there are two parts in this question that we need to solve. In the A part, we need to find the velocity of the ball 1.75 seconds after it was thrown. So suppose that after 1.75 seconds the ball reaches here, and the direction for the velocity vector will be tangential to the path, so something like that. So this will be the velocity vector vf. Now we're going to use the equations of motion here. So we can write that the final velocity vector, this will be equal to initial velocity vector plus acceleration vector multiplied with time. Now v naught we are given to be this much, so this is 16.6 meter per second x cap plus, now acceleration we have 9.81 meter per second squared y cap multiplied with time. Now time we have to take it to be 1.75 seconds. Now we can solve it further and we'll get the velocity vector vf to be equals to 16.6 meter per second x cap minus, this would become 17.2 meter per second y cap. Now this will be the answer for the A part. Now in the B part, we have to find the magnitude and the direction of this velocity vector. Okay, so magnitude, it's pretty simple. This will be equals to under root the x component square plus the y component square. X component we have 16.6 and its squared plus y component is minus 17.2 and it's squared. So we'll get this value to be 23.9 meter per second. So this will be the answer for the B part. Now here one more thing we have to find, the direction. So theta we have to find. So theta will be tangent inverse the y component over the x component. Y component we have minus 17.2, x component is 16.6, and on further solving we'll get this value to be minus 46.0 degree. Now let me represent this on this diagram, this angle. So this is our negative y direction and this is the positive x direction. So this angle theta we have calculated to be 46.0. And why this is negative? Because this is the below horizontal and we are measuring this angle in the clockwise. So we can rewrite this answer as, or we can rewrite that 46.0 degree below horizontal. Now in this question we are given that plane 1 taxis with a speed of 12 meter per second due north. This is our north direction and this is the west. So 12 meter per second due north. So vector would look something like that, the velocity vector for plane 1. This is the velocity of plane 1 relative to ground. Now next it says that plane 2 taxis with a speed of 7.5 meter per second in a direction 20 degrees north of west. So the vector would look something like that for the plane 2, and this angle we have 20 degrees. This is V2G. Now there are two parts in this question that we need to solve. In the A part, we need to find the direction and the magnitude of the velocity of plane 1 relative to plane 2. It's a pretty simple question and we have solved multiple questions like this. So the velocity of plane 1 relative to 2, this would be equals to the velocity of plane 1 relative to ground plus the velocity of ground relative to plane 2. Now we can rewrite this equation as, this is V12 as it is, this will be equals to V1g plus, now this vector we can rewrite as V2g and with a negative sign, because we know that V2g is negative of Vg2. The direction is reversed just, so we can write this way. Now it's pretty simple. We have to add these two vectors to find this velocity. Now V1g we already know it is 12 meter per second due north. So this we can write, this is 12 meter per second y cap. This thing we can write. Now this plus and minus will become minus here. Now this is V2g. Now V2g have two component in x and y direction. This would be its x component like this, and this will be its y component like this. So x component would be minus 7.5 meter per second cosine 20 x cap, and the y component will be plus 7.5 meter per second sine 20 degree y cap. Right? Now we can solve it further. So this is V12, this will be equals to, now this is as it is, this is 12 meter per second y cap minus, so we can use a calculator to solve this, and we'll get this value to be minus 7.0 meter per second x cap, then plus this value comes out to be as 2.56 meter per second y cap. Now this is 12 meter per second y cap, this minus will become plus 7 meter per second, sorry 7.0 meter per second x cap, this would become minus 2.56 meter per second y cap. Now we can subtract the y component, and x component I am writing in the front, so 7.0 meter per second x cap, and this would become plus 9.4 meter per second y cap. So this is the velocity V12, and if you wish I can also represent it on the vector diagram. This will be V12. Now we need to find the direction and magnitude. So magnitude is pretty simple. V12, this would be under root the x component square plus the y component square. X component we have 7.0 and it's squared, plus y component is 9.4 and it's squared. So we'll get this value to be nearly 12 meter per second. So this would be the answer for its magnitude. Now the direction theta. So theta we have tangent inverse the y component over the x component. Y component is 9.4, x component is 7.0, and on further solving we'll get this value to be 53 degrees. Now what is 53 degrees? So let me represent on the diagram. Actually this angle is 53 degrees, which is north of east. So we can write this is 53 degrees north of east. So this is the answer for the A part. Now next, in the B part we need to find the direction and the magnitude of the plane 2 relative to plane 1. Pretty simple, because we know that V21 is negative of V12, right? So we can write that V21 will be negative of V12. We have this thing, we can put it here, is minus 7.0 meter per second x cap, plus this is 9.4 meter per second y cap. So this would become minus 7.0 meter per second x cap minus 9.4 meter per second y cap. So this is V21. Sorry, this is negative sign here. Now the magnitude will remain the same for the velocity vector V21. So V21 will get this value to be same 12 meter per second, but the direction will change. This angle theta will change. So let me represent the vector first on the diagram. So V21 will be just opposite to this vector, so something like that. The magnitude will remain the same, just the direction is reversed, and this angle theta will be 53 degrees, but this would be south of west. Actually this angle we have 53 degrees, which is south of west. This is our north direction, this is the east, this is the south, and this is the west. So this will be south of west. So I hope you got the problem. If you have any problem, you can comment me in the comment box below. Now in this question we are given with this figure, and these are basically the small intestine and the large intestine of the human digestive system. Now suppose the food particles motion over a period of time is represented by these four vectors: vector A, vector B, vector C, and vector D. And the magnitude for vector A we have 8 centimeter. For vector B we are given to be 16 centimeter. For vector C we have 23 centimeter. And for vector D we have 5.6 centimeter. Now there are two parts in this question that we need to solve. In the A part we need to find the total displacement of the food particle. So the total displacement will be the vector sum of these four vectors. Let the displacement be delta R. This will be equals to vector A plus vector B plus vector C plus vector D. Now delta R, this will be equals to, now vector A we have 8, the magnitude for vector A we have 8 centimeter. This direction will be positive X and this direction will be positive Y. Now this vector A is along the negative X, so A vector we can write it as minus 8 centimeter X cap plus. Now vector B is along the positive Y, so we can write 16 centimeter Y cap plus. Now vector C is along the positive X, so this would be 23 centimeter X cap plus. Now vector D is along the negative Y, so this should be minus 5.1 centimeter Y cap. Now we can add the Y component with the Y component and the X component with the X component. So this delta R, this will be equals to 15 centimeter X cap. We have just added this one and this one. Now then plus, so 16 minus 5.1 is, sorry, this is not 5.1, this should be 5.6. So 16 minus 5.6 is 10.4. So this is 10.4 centimeter Y cap. And we can also represent this delta R on the figure also. This vector will represent delta R, the displacement vector. Now, but we have to find the magnitude. So for magnitude, it's pretty simple. Delta R will be under root X component square plus the Y component square. X component we have 15, Y component we have 10.4. So this will be equals to 18 centimeter. So this will be the answer for the A part. And we have to also give its direction relative to vector A. So we have to find this angle, this direction theta we have to find. So what we are going to do is we'll be calculating this angle theta, and we can subtract it, let it be theta dash, and we can subtract this theta dash from 180 degrees to find the angle theta, because this theta we have 180 degrees minus theta dash. Now theta dash is pretty simple. Now what would be theta dash? Now we can take two components. This is our delta R vector. This would be its X component for delta R, and this will be its Y component, and it's a right angle triangle, so we can use the trigonometric formulas to find this angle theta dash. So theta dash I am writing here. This theta dash would be tangent inverse. This is our Y component, which we have 10.4, divided by this is X component, which we have 15. This theta dash will come out to be as nearly 35 degrees. Now because we have to give our answer relative to vector A, so theta should be, this total angle would be 180, so theta would be 180 minus theta dash. So 180 minus theta dash is 35 degree, so this would be equals to 145.26 degrees. So this angle we have measured in this direction, which is the clockwise direction. So 145.26 degrees clockwise from vector A. We can write it here. This is clockwise from vector A. Now next, one more part we have. In the B part, we need to find the average, we are given with the average speed as 0.010 mm per second, and we need to find the average velocity over the time interval of the forward displacement. So we are given with the speed, and speed we know it is distance over time. Now from here we can calculate the time. Time would be distance over the speed. Now distance for the food particle, we have this 8 plus 16 plus 23 plus 5.6. We can write it here. This is 8 plus 16 plus 23 plus 5.6 divided by speed we are given with 0.010 mm per second. Now this is in centimeter, so we have to match the units. So we can do one thing, we can multiply this with 1/10 so that this mm is converted into centimeter. So the time will get this value to be equals to 52,600 seconds. Now it's pretty simple. We know velocity is delta r over delta t, and displacement we have calculated earlier to be 18 centimeter. So this will be 18 over delta t is this, which is 52600 seconds. Now on further solving, we'll get this answer in centimeter per second. Now we can do one thing, we can convert the units. We can multiply it with 1 centimeter is equivalent to 10 mm. Now we'll get the answer in mm per second. So this would be 0.0034 mm per second, millimeter per second. And what would be its direction? Think, pause the video and you can think. Now the direction would be same as that of delta r, and the direction we calculated earlier, this was the direction for delta r. So the direction for the velocity vector will be 145.26, and this is clockwise from vector A.